In the last lecture, we seen that what is the cyclic group. Okay, homomorphism, isomorphism, normalizer of an element, normalizer of a set. Okay, so today we will start the actual syllabus. The first theorem of our syllabus, first isomorphic theorem for group. Okay, there are three theorems are there for ring, for field. Okay, so here we will see the first isomorphic theorem for group. Okay, so here for group, right on. Okay, suppose let G and D G dash. Let G and G dash be the group. Be the group. And f is the function from G to G dash. Okay, that is what we have. F is the mapping from G to G dash is onto homomorphism. Is onto homomorphism. Okay, it means the phi satisfies the homomorphism property. Okay, F is preserves the operation and F is onto. That means every element belongs to G dash. There exists a pre-image in G. Okay, so let G and G dash with the group, and F is the function from G to G dash, which is onto as well as homomorphism. Then we have to prove that G dash. Okay, this codomain of this function G dash is isomorphic to G upon kernel of F. Okay, G upon kernel of F. That is the quotient group. G by kernel of F is what? Quotient group of G. Okay, let G and G dash be the group, and F is the function from G to G dash, which is onto as well as homomorphism. Then we have to prove this that this G dash is isomorphic. Isomorphic means 1 onto, and there exists a function between G dash to G upon kernel of G, this quotient group, such that that function must be 1 onto and homomorphism. Okay, any doubt in this theorem statement? Any doubt up here? Statement मध्ये काही doubt आहेत का?
No, sir.
Okay, now look at here proof. Suppose that let F be the function from G to G dash is what? What is given to us is onto homomorphism. Write down all first given things. Homomorphism. Okay, and we know that kernel of F is the subset of कोणाचा normal subgroup असतो? It is the normal subgroup of
G.
G. Very good. Okay. What is the definition of kernel of F? Kernel of F is nothing but the set containing all the elements belongs to, collection of those elements belongs to the set G, such that domain G, okay, what is the domain of F here? G. The collection of those elements belongs to G, such that F of X maps to, बोला पटकन. F of X is maps to बोला. F of X is mapped to E dash, where E dash is what? Where E dash is identity of G dash. जर तुम्ही नसत बोलाल तर मी जाईन पुढे, मी थांबणार नाही कोणत्या. Okay, what is kernel of F? Kernel of F is equal to X belongs to G, so that F of X is equal to E dash. Okay, X maps F maps to X to the E dash, where E dash is the identity of G dash. Okay, hence here the kernel of F is what? Normal subgroup of G. Therefore, G divided by, okay, G by kernel of F is what? Quotient group. Okay, एखादा quotient group define करायचा असेल तर तो हा काय पाहिजे, जो डिनॉमिनेटरला आहे तो काय असायला हवा, त्याचा नॉर्मल सबग्रुप असायला हवा. ओके, सो here the kernel of F is what? Normal subgroup of G. Hence G by kernel of F is what? Quotient group. Okay, so we can define the group G by kernel of F, which is quotient group of G. Okay, now let denote this kernel F. Kernel F is equal to n. Okay, तुमच्या नोट्स मध्ये हे मिस्टेक आहे. कर्नल ऑफ एफ इज इक्वल टू काय झालं तिथे, जी अपॉन कर्नल ऑफ एफ असं झालं तिथे. जी अपॉन कर्नल ऑफ एफ इज इक्वल टू एन झालं. ओके, हे मिस्टेक हा करेक्ट करा. ते कर्नल ऑफ एफ इज इक्वल टू एन. ओके, हा नाही आहे तिथे, तुमच्या नोट्स मध्ये असं लिहिलंय. सो लेट कर्नल ऑफ एफ इज इक्वल टू एन. ओके, सो hence n is what, normal subgroup of now G. Okay, kernel of F is always the normal subgroup of G. Now define a function. Now we define a function. Define a function gamma from G by n to G dash. Okay, असं का प्रूव्ह केलं आपण? Because we have to prove that G by kernel of F, that is n, is isomorphic to what? G dash. Okay, now here the gamma is the function from G by n to G dash. If this gamma is 1, 1 on 2 and homomorphism, then this G by n is what? Isomorphic to G dash. Okay, now here we define a function gamma from G by n to G dash such that, कसा define केलं function, such that gamma of ng, okay, हा काय तुमचा quotient group, the elements of the form quotient group what, ng is equal to f of g. Okay, for all ng belongs to G by n and this G belongs to capital G. Any doubts?
No.
Okay.
मैंने लीव करने की मीटिंग
such that gamma of ng is equal to f of g. What is g by n? G by n हा कसा दिसेल? What is the input of gamma here? G by n काल शिकवलंय cosets n into g such that this g belongs to capital G. Okay, if the binary operation is multiplication. Okay, if g by h kasa असेल? G by h. Okay, if the binary operation is addition, then this is just small a, where small a belongs to G. Okay, so here the input of the gamma of the form ng and is equal to f of g. F of g is what? F of g belongs to, f is the function. Look at here, f is the function from g to g dash. Okay, if g belongs to this g, then f of g belongs to g dash. Okay, म्हणजे या g साठी काय आलं तुमचं फंक्शन, gamma of ng is equal to f of g. म्हणजे हा f of g कुठे असणार तुमचा, g dash. Okay, any doubt up to here? डाउट आहेत का काही? Okay, such that gamma of ng is equal to f of g. Okay, now we have to prove that. We have to prove, okay, this gamma is well defined and what, 1 1. Okay, how to prove the well defined function? Take any two elements. If x1 is equal to x2, if it is implies gamma of x1 is equal to gamma of x2, then function gamma will be well defined. Okay, and how to prove the 1 1? F of x1 instead of f of, write gamma. If gamma of x1 is equal to gamma of x2, reverse case, this implies x1 is equal to x2. This implies what it implies, gamma is 1 1. Okay, if we prove that x1 is equal to x2 implies and implied gamma of x1 is equal to gamma of x2, then hmm, gamma is what? 1, 1 and well defined. Is it correct? Okay, how to prove the one oneness and well defined? If x1 is equal to x2, it implies and implied. Okay, if this statement true, then this will be true. If assuming this one, if this one is true, x1 is equal to x2, then function is gamma function is 1, 1 and on 1, 1 and well defined. Okay. Now let take any two element x1 and x2 belongs to G by n. But G by n, in the set G by n, every element of the form what? N G1. Okay, so let n G1 is equal to n G2, where G1 and G2, these are the two elements belongs to group G. Okay, so this implies and implied by post multiplying G2 inverse. This is G1 into G2 inverse. We get n G2 G2 inverse. Okay. Why? Because here the G2 inverse belongs to what? G. Okay. So this implies and implied. Okay. We have one result. If H A is equal to H, this implies and implied A belongs to H. Okay. हा आपला result आहे. Okay, if the binary operation is multiplication, then HA is equal to H, then A belongs to H. Or if binary operation is addition, H plus A is equal to capital H. This implies and implied A belongs to H. Okay. Now, this is N G1 G2 inverse is equal to N into E. Okay, G2 into G2 inverse is identity, which is equal to what? N. Okay. So hence this implies and implies this n G1 G2 inverse is equal to n. So this implies and implies this element G1 G2 inverse belongs to what? N. Okay, what is the reason? H into A is equal to H. This implies and implies A belongs to H. Okay, what is N? This implies and implies this G1 dot G2 inverse belongs to what? N is what? Kernel of F. Okay. If this element, whatever be the output of this one, if this element belongs to kernel of F, what is the definition of kernel of F? Look at here. एखादा एलिमेंट कर्नल ऑफ एफ मध्ये असेल तर हा कंडिशन सॅटिस्फाय करेल. Okay, so here what we get? F G1 G2 inverse belongs is equal to A dash. Okay, so here, wait a minute. If this G1 G2 inverse belongs to kernel of F, okay, so this implies and implied if you apply F on G1 G2 inverse is equal to A dash. Okay, but what is given to us? F is what? Onto homomorphism. Look at here. F is onto homomorphism. F is onto and always and also homomorphism function. And hence, this implies and implied F of G1, comma, dot F of G2 inverse is equal to E dash. So this implies and implied. This is F of G1 into F of G2 bracket inverse is equal to E dash. What is the reason here? F of X inverse is equal to what? F of X whole bracket inverse. Okay, this is the result we have. by post multiplying by f of g2, f of g1 into, this is f of g2 inverse into f of g2, okay, is equal to e dash into f of, this is g2, okay. So this implies and implied. What is the multiplication of these two one? This is f of g1 into e dash, which is equal to e dash into f of g2. Okay. Now f of g1 and f of g2 are the two elements belongs to what? G dash. Because f is the function from g to g dash. So f of g1 and f of g2 belongs to g dash, and e dash is the identity of g dash. Hence, this is f of g1 is equal to f of g2. But what is f of g1? F of g1 is equal to gamma of n g1 by the definition of gamma. Gamma of n g2. Okay, look at here. F of g1 is nothing but gamma of n g1. F of g2 is nothing but gamma of n g2. Okay, hence we get Don't-Start-Kellogg's theorem. If ng1 is equal to ng2, this implies and implied. If ng1 is equal to ng2, implies and implied gamma of ng1 is equal to gamma of ng2. Okay, hence gamma is 1, 1 and well defined. Okay, any doubt up to here? Try doubts ahead, friend. Now we have to put that gamma is onto. Okay, आपल्याला काय gamma is the isomorphic function. Isomorphic to g upon kernel of f to g dash. Okay, now here we prove that gamma is 1. Now, to prove that gamma is onto. माझा आवाज येतोय का नाही? ते तरी सांगा. हॅलो. समजतंय का काही डोक्यावरून जातंय?
येतोय सर, येतोय.
लक्ष द्या आणि रिप्लाय करा. Okay, now we have to prove that the gamma is onto function. What is the ontoness? Onto is equal to what? Range is equal to what? Codomain. Okay, range is equal to codomain. We have to prove that. Hence, that is, we have to prove that every element, if suppose this one is A and this one is B, and f is the function from A to B. For every element of B, there exists a pre-image in A. Okay, म्हणजे तुमच्या या बी मध्ये कोणताही एलिमेंट रिकामा नसायला पाहिजे. So range is equal to what? Codomain. Okay, for every and each and every element of codomain, we have at least one pre-image in domain. Okay, what is here? What is the domain of this gamma? G by n. What is the codomain of this here gamma? G dash. Okay, for each and every element belongs to G dash. If we get the pre-image in G by n, then the function is what? Onto function. Okay, so let's take y with any element belongs to G dash. Okay, y with any element belongs to G dash. So there exists G belongs to capital G such that this f of G is equal to y. Okay, this is the function gamma. This is the function f. F is the function from G to G dash. Okay, f is what? Onto homomorphism. Onto and homomorphism. That means this function is for every element in G dash, we get pre-image in G. Okay. If you take y belongs to what? G. Okay, here y belongs to G dash. Okay, suppose this is y. Y is of the form what? F of g. Why? Because f is on. Okay, so here f of g is equal to y. Yeah, aside g exists into capital G modulus such that y is equal to f of g. Okay, what is the reason? Since such that f of g is equal to y. Since what is the reason? F is on f is on 2. Okay, thus for this small g, okay, for this small g, okay, which one? This one. This small g belongs to capital G. We get element n into g. Okay, belongs to that quotient group g by n. Okay. या g साठी मला कुठं फंक्शन कुठं एलिमेंट मिळाला होता या g by n. Okay, this is ng. Okay, and hence for y is equal to f of g belongs to g dash, there exists g belongs to capital G, and this ng कुठे जाईल माझा g by n, such that this gamma of ng, okay, apply this gamma on this element ng. By the definition of gamma, gamma of ng is equal to what? Of g, which is equal to y. Okay, so hence for every element belongs to domain, we get pre-image in domain. Okay, तुमचा हा साय फंक्शन कुठे आहे इथे? Okay, g dash मध्ये y म्हणजे हा तुमचा कुठेतरी y असेल. For every element, for arbitrary element of this y. Okay, so for every any element y belongs to g dash, we get there is an image, pre-image in domain. Hence, gamma is what? On 2. Okay, any doubt? Okay, now
No.
we have to prove that gamma is homomorphism. Next step to prove that this gamma is homomorphism. Okay, this gamma is homomorphism. That is to prove that gamma of elements belongs to domain ng1 dot ng2 is equal to what? Gamma of ng1 into gamma of ng2. Okay, we have to prove this condition. So give it is in equation 1. Okay, this is 1. Oneness, ontoness is second. Okay, now consider the left hand side of the above equation. Consider gamma ng1 into ng2, which is equal to what is h into a? Ha into hb is equal to what? Hab. Is it correct?
Yes, sir.
Yes, sir.
Or h plus a plus h plus b. तर काय लिहितो आपण? H plus a plus b ना?
Yes, sir.
Okay, similarly, whatever be the binary expression. So here gamma of ng1 into ng2 is equal to what? Gamma of ng1 g2. Okay, by the definition of gamma, gamma is equal to gamma of ng1 g2 is equal to what? F of g1 g2. Okay, look at here, what is gamma? Gamma कसा define केलं तुमचं function? Gamma of ng is equal to f of g. So gamma of ng1 g2 is equal to f of g1 g2. But f is what? On 2 and homomorphism. Hence, f satisfies this property. Okay, give it here reason. HA into HB is equal to HAB. Hmm. By definition of gamma. Okay, F is homomorphism. Okay, again, what is FG1? Gamma of NG1. What is FG2? Gamma NG2. Okay, again, by definition of gamma. Okay, so this implies gamma of NG1 into NG2 is equal to gamma of NG1 into gamma of NG2. Due to the equation number third. So from 1, 2, and 3, we get what we get? We get gamma is the function from what? G by N to G dash. Sorry, G dash is isomorphism. Isomorphism. Why? Because gamma is 1, 1 on 2 as well as homomorphism. Okay. Hence, G by N is isomorphic to G dash. This implies G by what is N? Kernel of this function f is isomorphic to G dash. Means the proof. Any doubt?
No, sir.
Okay. ओके काल तुम्हाला एक एक्झाम्पल सांगितलं होतं हा जी बाय एच कसा असतो ग्रुप इफ ऍडिशन इज द बायनरी ऑपरेशन ऑन जी देन एच प्लस ए such that a belongs to what g ना ओके टेक हियर कालचं एक्झाम्पल सांगतो मी म्हटलं ना काल सांगतो मी उद्या सांगतो टेक जी इज इक्वल टू झेड प्लस okay what is z plus 0 plus minus 1 plus minus 2 up to so on and take h is equal to the group generated by 3 what is the element of this one 0 plus minus 3 plus minus 6 up to so on okay now a plus h हा कसा असेल group now take this small a belongs to small a is equal to 1 okay so 1 plus h that is equal 1 plus h is what this is group generated by 3 so add each and every element 1 प्रत्येक एलिमेंट मध्ये तुमच्या काय करायचं 1 ऍड करायचं कशामध्ये 3 तर काय येईल -1 ओके 0 मध्ये 1 ऍड केल्यानंतर काय येईल 1 -1 मध्ये जर ऍड केला तर मी काय येईल -1 मध्ये 1 ऍड केला काय येईल इथे 0 -2 मध्ये 1 ऍड केल्यानंतर -1 and up to so on okay wait a minute sorry add 1 each and every element of this set okay
Yes, sir.
0 मध्ये 1 ऍड केल्यानंतर 1 येईल okay now 4 now 7 up to so on and here -2 -5 okay so this is 1 plus h now 2 plus h का येईल 2 plus subgroup generated by 3 okay add 2 each and every element of 3 subgroup 3 h okay 0 plus 2 2 okay 3 plus 2 5 and say 8 then 11 up to so on and left side काय येईल इथे -1 -4 -7 up to so on okay is it correct what is here a is equal to 1 A is equal to 2. Now take A is equal to 0. Okay, 0 plus capital H is equal to 0 plus subgroup generated by 3, which is equal to, add each and every element 0 in H. 0 plus 0, 0. 3 plus 0, 3. Up to so on. 3, 6, 9. Here as it is, minus 3, minus 6. To so on. Okay. Now take A is equal to 3. Okay. Take A is equal to 3. 3. So what we get? 3 plus H is equal to, Kyle, 3 plus subgroup generated by 3. Okay. Now 0 plus 3, 3. Plus 3, 6, up to so on. 6, 9. And here, minus 3 plus 3, 0. Minus 3, minus 6 plus 3 is minus 3, minus 6, up to so on, which is equal to this one. Look at it. हा दोन्ही सेट कसे आहेत? सेम आहे. Okay. Hence, from above, we get 0 plus h is equal to 3 plus h is equal to 6 plus h. हा सगळा सेट सेम आहे. Okay. 1 plus h is equal to काय येईल? 4 plus h is equal to 7 plus h. हा सगळे सेट सेम आहे. Okay. So here G by subgroup generated by 3, that is equal to, what is Gz upon subgroup generated by 3, contain how many elements? 3 elements. Which one? 0 plus h, 1 plus h, and 2 plus h. 0 plus h means what? Which is equal to h, na? Is it correct? 0 plus h is equal to h. Okay. This is h, 1 plus h, or 2 plus h. 2 plus h. Okay. आता तुम्हाला एक कंडिशन सांगितली होती. काय सांगितली होती? इफ a plus h is equal to, जर h येत असेल, okay, if a plus h is equal to h implied a belongs to h. Okay, what is h here? H is ideal generated by 3, which is equal to minus 6, minus 3, 0, 3, 6, up to so on. Okay. Now take A with any element belongs to H. Okay, या H मधलाच कुठला तरी एक एलिमेंट घेतला. Suppose A is equal to minus 3. Okay, so minus 3 plus H. What we get? Okay, add minus 3 in each and every element of H. 0 minus 3, minus 3. 3 plus minus 3, 0. 6 minus 3, 3. Okay, and up to so on. And here minus 6. So what we get? This is H again. So hence, if A plus H is equal to H, A plus H is equal to H, then it implies A belongs to H. जो हम minus 3 के साथ में कितना होना साल है? Minus 3 belongs to H. है का minus 3? Yes. Okay. Any doubt? Okay. Similarly,
No, sir.
this condition holds, then A belongs to H. If A belongs to H, then A plus H is equal to H. Okay. So here G upon kernel of F, G by kernel of F is isomorphic to G dash. So this is the first theorem of isomorphism. Okay. Now the second one, second isomorphism theorem. Next theorem is theorem number 2. Okay. प्रत्येक theorem ला नाव दिले. Theorem number 1. Okay, म्हणजे by previous theorem सांगताना कळेल तुम्हाला कुठला नंबर आहे theorem. Theorem number 1. म्हणजे किती theorems आहेत हे लक्षात येईल. Now the second theorem. Second isomorphism theorem. Second isomorphism theorem. Okay, what is the statement? Let capital H each subgroup Okay, if capital H is subgroup of capital G. Okay, that is H is subgroup of G. And capital N is normal subgroup of G. That is, this N is what? Normal subgroup of G. Then we have to prove that this H into N, okay, product of two subgroups divided by N, that is Hn upon N or Hn by N is isomorphic to H intersection H upon H intersection N. Okay, if H is the subgroup of G and N is normal subgroup of G, then we have to prove that Hn upon N is isomorphic to H upon H intersection N. Okay. स्टेटमेंट खूप अवघड आहेत, प्रूफ अवघड आहेत बरं काय, नीट लक्षात ठेवा. आणि काल काय झालेलं ते आज आपण वाचलंच पाहिजे, आज झालेलं आपण वाचलंच पाहिजे, नाही तर पुढचं लेक्चर काहीच करणार नाही. ओके, बाकीचे विद्यापीठ सुरू होत आहे, जर तुमचे सगळे एक्झाम जर ऑफलाईन झाले तर अवघडून बसेल, तुम्हाला प्रत्येक प्रूफ लिहावं लागेल. ओके, एक प्रूफ तुम्हाला 4 ते 5 वेळा लिहून काढावं लागेल, मगच तुमच्या लक्षात राहील ते. ओके, नाउ द प्रूफ. एनी डाउट इन द स्टेटमेंट? H is the subgroup of G and N is the normal subgroup of G, then we have to do that Hn upon N is isomorphic to H upon H intersection N. Okay, write down all given things first. Given H is the subgroup of G and N is normal subgroup of G. Okay, so we have result one. If H is the subgroup of G, N is the normal subgroup of G, so this implies N is normal subgroup of H into N. Okay, by using result. Which result? Okay, कुठला result? या सिस्टम मध्ये टेक्स्ट बुक मध्ये आहे ते पहा. ओके, बेसिक चा रिझल्ट आहे. N is normal subgroup of H. If H this is subgroup of G, this N is normal subgroup of G, then N is normal subgroup of the product of this one, H into N. Okay. Now, and H intersection N be the normal subgroup of H. Okay, this is again by using result. Okay, suppose this one is group H, this one is N. What is this one? H intersection N. So this is the normal subgroup of this H. Okay, this one. Normal subgroups. Okay. So H intersection N is normal subgroup of H. Okay. Now, एखादा क्वेश्चन ग्रुप जर डिफाइन करायचा असेल D by H, याची आयडेंटिटी काय असते? G by H ग्रुपची. What is the identity of G by H? Identity element of G by H. Identity element of here Z upon काय होता? Idea subgroup generated by 3. काय आला हा set? What is this set? This one, na? Okay, this one is the set. What is the identity of this quotient group? बोला पटकन. 0 plus H. Okay, 0 plus H is nothing but what? H. This H is nothing but what? Subgroup generated by 3. That is, the denominator is what? Identity of this quotient group. Okay, for every quotient group, this denominator, whatever will be the denominator, whatever will be the normal subgroup, this H will be the identity of this G by H. Okay, so here N is the normal subgroup of Hn. So we can define mapping from phi from H to Hn divided by N. Okay, such that phi of H small h, input is small h, is equal to This is capital M as it is. This is H small h. This for all H belongs to capital H. Okay, हा आउटपुट आहे का या ग्रुप या ग्रुप मधला? येस. त्याचा नेचर कसा असेल? या सेटचा नेचर n into a, where a belongs to Hn. Okay, or a belongs to H into what is the nature of this group? Na, where a belongs to nh. Okay, okay, this a we can write in the for this form: e into a belongs to nh, where a belongs to n, a belongs to h. Okay, so hence we can define a function phi of h is equal to nh for all h belongs to capital H. Okay, now again we have to prove that this one, this h divided by h intersection n, this group is isomorphic to this one. Okay, now first prove this function is 1 on 2. Okay, first we prove on 2 if the kernel of this function kernel of phi, if we do this h intersection n, then by using first theorem, by fundamental theorem of isomorphism, h upon kernel of h is isomorphic to this g dash. Okay, आधुनिक g dash. Okay, म्हणायचं g, assuming this was g, by using now first fundamental theorem, g by kernel of f is isomorphic to g dash. Okay, then h upon kernel of f, kernel of phi here, is isomorphic to h n divided by n. And also we have to do that this kernel of phi is equal to h intersection n. Okay, look at that. We defining phi of h is equal to nh. Consider phi of h1 h2 is equal to, by the definition of phi, this is n h1 h2. Okay, you know that this is right by definition. What is the reason? Now this is n h1 into n h2. Okay, what is the reason? HAB is equal to what? HA into HB. Okay, what is n of h1? This is phi of h1 into this is phi of h2 by definition of again phi. Okay, hence we get phi of h1 h2 is equal to phi of h1 into phi of h2. Okay, this is the one. Okay, now consider second step. Consider this nh belongs to hn upon n. Okay, कसा असतो g by h चा प्रत्येक एलिमेंट कुठल्या फॉर्ममध्ये असतो h, this a belongs to g ना, काय हा nh, where this h belongs to this h belongs to what? hn ना. Okay, any doubt? काय डाउट असतील तर विचारू शकता. This nh belongs to hn divided by h, and this implies this h belongs to what? This one. Okay, this a belongs to just this h belongs to h. So this implies this h into e. We can write this h into e belongs to hn. So this implies the product of two subgroups. That means this h belongs to this h, and this e belongs to capital N. Okay, so this implies h belongs to capital H. Thus, for what we assume is nh, categorically nh belongs to hn upon n. So there exists h belongs to capital H. Okay, such a there. Wait. such that phi of h is equal to nh. Okay, phi का होता है, this is our say h. This is h n upon n, and this one is phi. Okay, here the element of the form nh. So we get for each and every element belongs to the codomain, we get the pre-image in domain. Hence, such that phi of h is what? Phi of h is equal to nh. Okay. So this implies phi is on 2. Okay, any doubts up to here? Second one.
No, sir.
First, we prove here homomorphism condition. Second, in the second one, we prove the onto condition. Okay. Now, what is the kernel of phi? By the definition of kernel of phi. एखाद्या फंक्शनचा कर्नल कसा डिफाइन करतोय? Collection of elements belongs to the domain. What is the domain of phi? Look at here. What is the domain? That is the domain of our phi. So collection of elements belongs to domain such that phi of x is equal to what? Identity of codomain. What is the identity of codomain? Which identifies and equally domain. What is the identity of this one? This factor group. बोलना पटकन. What is the identity of this factor group? N ना? आहे काय लक्ष? धनशेट्टी काय? पूनम जयजिंगड काय यांचं नाव? मेटकरी, मोरे, जाधव आहेत काय सगळे? कळते का काय सांगतोय?
Yes, sir.
बोलत का नाही?
Yes, sir. Sir.
Okay. Identity of factor group is काय जो काही डिनोमिनेटर असेल तो आयडेंटिटी एलिमेंट असतो. ओके, सो phi of x is equal to n ना? इथे x नाही येणार बिकॉज हियर डोमेन इज h असल्यामुळे काय घेऊया आपण स्मॉल h घेऊया. ओके, स्मॉल h belongs to capital H, such that phi of h is equal to n. ओके, आता तुमचा डेफिनेशन आहे का phi. नाउ फर्दर let this small h belongs to kernel of phi. So this implies and implied phi of h is equal to identity of codomain, that is n. Okay, by the definition of phi of h, what is phi of h? Nh, which is equal to n. Okay, if by definition of phi. Okay, so this implies this h belongs to what? And because h into a is equal to h, so this implies and implied a belongs to h. So here h belongs to what? N. Okay. So this implies, what implies? h हा माझा कशामध्ये आहे एलिमेंट? कॅपिटल h मध्ये पण आहे. h हा कशामध्ये आहे? कॅपिटल n मध्ये पण आहे. This implies h belongs to h intersection n. Is it correct? Okay. Therefore,
Yes, sir. Sir.
kernel of phi. Therefore, kernel. Okay, implies and implies statement. The hard true असेल, hard condition true असेल तर hard true. आणि hard true असेल तर hard true होईल आणि hard true असेल तर hard होईल. Okay, so here the kernel of phi is equal to what? ह्याच्यात एलिमेंट घेतला तर कसं राहील? h intersection मध्ये. If you take the element belongs to h intersection n, then it belongs to kernel of phi. It implies kernel of phi is nothing but h intersection n. Okay, by previous theorem. Hence, first isomorphic theorem, we get Okay, try some examples of the first theorem. If y is the function from g to g dash, then g upon kernel of phi is isomorphic to g dash. Okay, तो g dash नहीं है, तो g चे ऐवजी h आहे, g dash चे ऐवजी h upon n आहे. Okay, आणि kernel of phi काय आहे तुमचा h intersection n आहे. Okay, g is what h, so we get h upon kernel of phi by first isomorphic theorem. Isomorphic to what is g dash here? G by n, n upon n. So this implies h divided by what is kernel of phi? H intersection n. It's isomorphic to h n upon n. Hence the proof. Any doubts up here? Okay, here's the conclusion.
No, sir.
Okay, h into n upon n isomorphic to h h upon h intersection n. Okay, so these are the first two isomorphic theorem. So in the next lecture, we will study the third isomorphic theorem. Okay, wait a minute. Up to here, any doubt? Try doubt was thinking which other?
No, sir.
Okay, so remaining part we will see in the next lecture.